Hi, I'm Conlon Foster, and this is Lab 8 Op-Amp Circuits. The Arduino sketch for the comparator circuit supplies 2.5 volts to the inverting input. As the potentiometer causes the voltage range to change, the LED gradually shifts brightness. For an ideal non-inverting amplifier, we perform Kirchhoff's current law at the inverting terminal. The gain is equivalent to the ratio of the output voltage divided by the input voltage, or in this case, 1 plus R2 over R1. This is the unity gain amplifier circuit, better known as the voltage follower. When this is idealized, the output is equivalent to the input. In the Arduino code, our values for the different voltages are converted from analog units to volts. In the video, we can see that the inverting input voltage and output voltage are completely equal, even obscuring the green in the processing table. There's a plateau that I did not expect, however, as the output voltage generally matches the input voltage, but will be held constant at about 1.9 volts if the input voltage goes below this. My intuition states that if my physical op-amp were ideal, then this would not be the case. The inverting amplifier follows, with its unique ground state and series of resistors. When this unique ground state is approximated to zero, then the gain for the given resistances is equivalent to -10. In my Arduino code, I have added a string for the voltage at the non-inverting input. The input voltage also becomes the difference of itself and the ground state of 2.5 volts. The input voltage now ranges from -2.5 to 2.5 volts. The inverting input voltage stays slightly more compact within the 0 to 5 volt range due to its space as a voltage divider. The output voltage plateaus at 4.25 volts and 1.9 volts. This inverts the input voltage as, in my overly simplistic analogy, the output voltage becomes high as the input voltage is low and vice versa. Lastly, we have an integrating amplifier circuit. The capacitor in this circuit causes the output voltage to vary as a function of time. More specifically, it is directly related to the integrand input voltage as a function of time. The impedance for a capacitor is equivalent to the complex number of 1 over j, where j is the square root of -1, multiplied by the natural frequency and capacitance. This relationship, in series with the resistor, causes the relationship between the input and output voltage to be representative of an RC circuit. No change was necessary in my Arduino and processing code, as the sketches that worked for the inverting amplifier also work here. We can see that the inverting input voltage varies directly with the input voltage, which is to be expected. As in the previous circuit, this setup acts as a voltage divider. The output voltage, where it once varied, now is explicitly one value or the other, depending on the charged or discharged state of the capacitor.